Hi, I'm about to graduate from a QA group, and I thought it would be cool to actually try to present my dissertation in a 3-minute talk. So let's see if I can do it with the simplicity that pretty much everybody could understand it. So my possible title for a dissertation would be Manipulation of Macromolecules. And if you go into any kind of dictionary, it turns out that manipulation word usually comes from manus, which means hand in Latin. So there's the root of the word. So there's the hand, and macromolecule not drawn on scale, and because of that reason, there's no way that you actually can manipulate these molecules through a poke, or let's say a pinch. But what you can do is introduce a chemical modification. So I'm actually going to be talking about manipulation of macromolecules through such a chemical modification, and the chemical modification itself will be a cross-linking. And I'll be talking about some applications in coatings and catalysis that we're able to achieve through these modifications. So here is the concept of cross-linking. You take your macromolecule, or polymer, and you link the strands there through some kind of chemical modification, so now they're cross-linked. So let's talk about coatings first. If you take a naturally occurring macromolecule, alginate, and you exchange the sodium ions with calcium cations, what happens, you cross-link these chains of macromolecule, and you can use it to trap a dye and, let's say, just disperse it on a turf, and that is the coating, a temporary logotype. Why is it temporary? Because it turns out that the first application of the calcium ions, and then if you take the logotype or the mask and then introduce that macromolecule and exchange the sodium with the calcium cations and trap the dye to make this, it turns out that calcium is can only be there temporarily. So if you want to remove it, you just need to remove the calcium, which is evident from the letter C here, and then you can just wash it off. So the significance of this is that it's eco-friendly coating, and also it can be removed really easily. So how about applications in catalysis? We figured that, well, I guess we discovered by chance that certain polymeric catalysts, which I'll get in a second, can be dispersed in a polar droplet in a nonpolar batch solvent. So it turns out then if you take this polymer and you cross-link it only at the surface of that droplet, you can make this semi-permeable microcapsule that traps the polymeric catalyst inside. And as Sarah and other people actually already mentioned, you can use this catalyst to facilitate a conversion of an aldehyde into this nitroalkene species. And Sarah already showed that you can use this catalyst in combination with a nickel-based catalyst that otherwise would be incompatible unless this catalyst is encapsulated, as I showed. And you can do 2 reactions in one pot. And the significance of that is pretty simple, or pretty evident, I should say, that instead of 2 steps and 2 vessels, you have 2 steps in one pot, which decreases waste and boosts productivity. One of the reasons why we think this is working to protect the interior catalyst from the outside nickel catalyst that otherwise would poison it is that we have unique microenvironment inside. And it turns out that methanol and polymer, which is one of the solvents, phase separates from toluene, which is the other solvent in that one-pot reaction. And because of that unique microenvironment, we think that prevents 2 catalysts to interact. And actually, you can see here that toluene forms this colorless droplet, while methanol and polymer that's labeled with red forms the other phase. And there's your microenvironment. So there it is. Manipulation of macromolecules through chemical modifications of cross-linking. And I guess since I'm going to be done in a month and a half, I can just relax now.